Good morning. This is your stat sensei, Mr. Spensei, and this is a two sample proportion hypothesis test. And so on needing more Coke, and this is part of our test review. And this we're going over the same problem that we did in the warm up, but we're actually going to run the test all the way through. So our scenario need more Coke. Caffeine is a daily staple for many Americans, helping them stay alert and productive. While coffee is a common choice, some prefer Coca-Cola for a milder boost. Many believe the caffeine in Coke enhances focus, while others argue it has little effect compared to coffee. To examine whether drinking Coke improves alertness and efficiency, researchers conducted a 3-year study on randomly selected adults. Okay, super important. They're telling me we have a random samples. Participants were divided into two groups. Group A, 1,120 individuals who drank at least one Coke per day. So this is my sample size. So that's what the N is for. So sample size for those who drank Coke out of a population of 3.9 million Coke drinkers. All right, Group B, 1,060 individuals. So this is my who drank no Coke. All right. So this is my sample size for no Coke. So this is what the NN is for. And my population for no Coke is 3.1 million. Each participant completed quarterly cognitive assessments measuring reaction time, sustained attention, and task efficiency through memory recall tasks, reaction-based challenges, and decision-making exercises. By the end of the study, researchers analyzed the proportion of individuals who showed measurable improvements in alertness and efficiency over time. Results showed that 392 in Group A demonstrated noticeable improvement. So 392 Coke drinkers had improvement. So 392 out of 1,020 or 1120, which is what we have, and compared to 375 in Group B. So 375 out of the 1,060 non-Coke drinkers. All right. We also said that P hat equals X over N. So that's where the 375 or once 375 non-Coke drinkers showed improvement versus 392 of the Coke drinkers. And when we divided that out, this is what we get. We also know because it's a hypothesis test, we're going to need P hat C, which we calculated here using this formula. So at alpha equals 0.05, does the study provide convincing statistical evidence that Coke drinkers are more alert and more efficient than non-Coke drinkers? Well, right there we have X1 and X2, N1 and N2. That's for our P hat C. And we just plugged in. When we plug in, we get 0.3518. All right. So what do we need? Well, we need P hat 1 and P hat 2. We need P hat C, which we have right up there. And we need our sample sizes. Well, when we draw these, we're going to be centered on zero because there's an assumption of no difference. And we'll look at that when we look at our hypothesis. Just comes from our HO. All right, that's where that comes from. All right, where did this come from? Well, I subtracted, you take 0.35, 0.35 minus 0.3537, and we get negative 0.0037. All right. And at alpha equal 0.05, does the study provide convincing evidence that Coke drinkers, so that Coke is greater than non-Coke? All right, so this is what we're looking for. Is it greater than? All right. Looks like it's not going to be because we have a negative value. All right. Continuing on. So for this formula, I needed P hat 1. Well, I have P hat 1. That's right here. I need P hat 2. And that's right there. And then I also need P hat C here, there, and this is where it came from. All right, so we're going to go ahead and plug into our formula. And all we did was just plug in and where this is P hat 1. P hat 2. And this right here is our P hat C. Also note, we get these lids back on this. We have our sample size N1 listed right here and N2 listed right there. All right, our hypothesis. Our hypothesis is that there's no difference. So our HO, P1 minus P2 equals 0. Our alternative hypothesis, HA, P1 minus P2 is greater than 0. Please remember, this 0 that shows up right here is that 0. That's how they tie together. Okay? All right, we're running a two proportion z-test. In case you forget, here's how you go, stat test. And we have two samples and it's proportion. So there it is. The 2 stands for two samples. So two sample proportion z-test. And our parameters, because it's two proportions, we're going to have two parameters. Let P1 equal the true population proportion of individuals who showed improvement or for individual alertness when drinking at least 1 Coke per day, or for showing who show increased alertness. And P2 equal the alertness level for those who true population proportion of alertness for those when drinking no Coke. All right. So our conditions, well, let's go back. It says it was randomly selected. So we have a random sample of 1,120, and we have a separate random sample of 1,060. And because they're randomly selected, two samples, we have two independent samples. So that I combine these together, and that's the way they're done on your recipe. But we have two independent random samples. All right, number 3, we need to check the N is less than 10%. Well, what are my population sizes? Population for Coke is 3.9. Population for non-Coke is 3.1. So if I take my sample size for the Coke drinkers, the 1120 for the Coke drinkers, and multiply it by 10, I get 11,200, and that's less than 3.9. This is less than 10%. 1,060 times 10, that is less than 3.1. So it's also less than 10%. So N is less than 10%. So it's not too big. Our sample's not too big. So that's good. Now we need to make sure it's big enough. Well, this is where we have to use P hat C. All right. And P hat C, we calculated above. I'll look at it in just a moment. But we're going to need it on both sides. And remember, it's just x1 plus x2 over n1 plus n2. And we got 3518. Well, my sample size for the Coke drinkers was 1120. So 1120 times 0.3518 is 394. That's bigger than 10. Then I have 1120 times, or parenthesis 1 minus 0.3518. And that's 725, and that's also greater than 10. So this sample is big enough, but just because I still have to check the other sample to make sure it's large enough. So 1,060 parenthesis 0.3518 is 372 greater than 10, so it's good. And then 1,060 1 minus 0.3518, and that's, I messed up, 1,060 parenthesis 1 minus 0.3518 is 687, which is also greater than 10. So both samples are large enough, and you really need to make a note to say that. All right, so we're ready to run the test. So here's what we need to do. We need to input our information. So stat test, two proportion z-test, and with 392 Coke drinkers out of 1120 show increased alertness, and 375 out of 1,060 non-Coke drinkers and we wanted a greater than. And when we calculate, we ended up getting a negative z-score and a very large p-value. All right, probability z is greater than negative 1.844. Excuse me. Check that real quickly. Stat test, two proportion z-test. All right, probability that z is greater than negative 0.1844 equals 0.5731. All right, so 0.5731 is much larger than 0.05, so we fail to reject. Please remember, this whole thing is going to be our first two sentences. Our p-value is 0.5731. P-value is 0.5731, which is greater than 0.05, our alpha 0.05. We failed to reject a null. That's our first two sentences. It comes directly from that decision box. There is not sufficient evidence to suggest that the true population proportion of individual alertness when drinking a Coke a day is more than the individual alertness when drinking no Coke. All right, so let's look at the more real quickly. You're probably tired of this by now, but that more comes from here. More is greater, all right? Greater than the individual drinking no Coke. And always want to stress how important it is to have good parameters because that's what we have right there. All right. We always have to restate our parameters, which were up here. Okay. So appreciate you watching and look forward to seeing you on the next one. Thank you.